Good morning and hello. We are continuing our discussion of proofs in a geometrical setting. And today we're going to be proving, first of all, here a pair of triangles are congruent. We're going to look at this with a flowchart proof. The thing that's nice about it is it allows us to see hierarchy. It allows us to see which things have to precede certain other things. Then we're going to look at an alternate form of a proof that we'll call a two-column proof, or other names for it, I suppose. But first, before we do that, let's review some of the things we know that we can use as reasons in this domain. So this is based on the list that we developed and I wrote in uh, a presentation recently. And again, when I zoom out here and you see the whole thing, you might want to consider pausing, adding to your list of reasons. Make sure you've got one that you're thinking about, you're developing, and you can use these things when appropriate. One of the things here is given information. It can be part of a proof. It could be, and the reason for that simply given, and that's true of angle measure, side lengths, or sometimes congruence check tick marks from diagrams. They tell us that things are true. Other things that we can use are the triangle angle sum theorem. It simply states that the three angles in a triangle add up to 180. If we know two angles in one diagram, we can use that information to figure out what the third one is if we need that separately. The Pythagorean theorem, right? The leg squared plus the other leg squared is equal to the hypotenuse squared. Definitions. We've got the definition of what are congruent angles. Basically, they're angles that have the same length or a same number of degrees. What are congruent segments? Those are segments that have the same measurement, same number of centimeters or inches. What are congruent triangles? Those are triangles that have six things that are true, right? All three pairs of angles and all three pairs of sides are congruent. So we can definitely refer to the definition, and it goes both ways, right? If we're given that two angles are 30 degrees, we can say that they're congruent to each other because they fit the definition of congruence for an angle. If we have something called an angle or a segment bisector, it cuts the object that is being talked about into two congruent objects. So let's say, for example, that I have a segment, I'll call it segment A to B. And let's say that I tell you that C is a segment bisector. Well, if I tell you that C is a segment bisector, then you know that segment AC is congruent to segment BC, right? So, and that would be true for angles also. If you've got an angle bisector for an angle that's 60 degrees, it cuts it into two congruent angles that both measure 30 degrees. Reflexive property. An object is congruent to itself. It's also equal in length to itself, or equal in measurement to the number of degrees it has. So reflexive property of equality and of congruence. If we have a pair of parallel lines that are cut by a transversal, there's many different angle pairs here that are congruent or they are supplementary. And I give you just a few here. I've highlighted two angles and I've labeled them corresponding. Those aren't the only pairs of corresponding angles in that diagram, but they certainly are corresponding. And if the lines are parallel and they're cut by a transversal, then the corresponding angles are congruent. Also, the alternate interior angles are congruent, and you can see I've marked those in red. They're on alternating sides of the transversal, and they are inside or in between the parallel lines. So alternate interior, and the green ones I marked were alternate exterior. So again, don't get hung up on just these ones that I've marked. There's other ones that are true. I guess another pair that I didn't forget. It really doesn't have anything to do with the parallel lines, but if you have two line segments that intersect, it is always the case that the angles that are don't need that to become a shape. The angles that are opposite each other are called alternate interior angles. Or no, not alternate. They're called vertical angles. And it has nothing to do with them being vertical or horizontal. It's just the angles that are across from each other whenever two lines intersect. So those two angles that I marked are congruent because they're vertical angles. And these angles are also congruent because they're vertical angles. That's a good one to, I should list that. Vertical angles. And Then we've got our list of triangle congruence conditions, right? These are I think we're up to 5. These are the 5 ways that we've said so far that we can establish that we have pairs of triangles that are congruent. Angle, side angle, 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 and then the side, 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 side angle, side, and hypotenuse leg. So keep these in mind as we are moving forward here. These are reasons that we can use to establish congruent triangles. If you don't have a list like this, consider pausing, building a list, maybe going out and researching and finding a list you like better. So let's come back to this diagram. So remember, in a flowchart proof, we have these ovals, and inside of the ovals, we assert something is true. And then off to the side, we write down why we're saying that thing is true. So the first thing I'm going to say is true is I am going to say that, I'll just say this given thing, right? I'm going to say that AD is congruent to AB. And the reason for that is it's right here. It's given information. So given, G-I-V-E-N. And I can see that it's given on the diagram as well because of the tick marks. The next thing that's up here is it tells me that CA is doing something special to angle bad. It says that CA is a bisector of angle BAD. So that's useful because I know that a bisector cuts an angle into 2 congruent angles. So I'm not marking these congruent with tick marks, but I'm putting these little green lines here. I have that those angles, I can get that those angles are congruent to each other. The other thing that I see that I have here is I definitely have another congruent side, although it's not marked. It doesn't say that it's congruent. It's the fact that CA is in both triangles, right? So I can say that CA is congruent to itself by the reflexive property. So let's go ahead and with that thing, I'll just put a little red dot here, remind myself that I'm going to get that's congruent to itself. And when I look at this, then I can see that these are fitting the side angle side pattern, right? I've got this side, and then this angle, and then this side. So they're definitely fitting the side angle side pattern. So I'm going to be using SAS to get my triangle congruence. So let's put all the rest of these things into the proof. Let's start with my bisector. So I'm going to just go ahead and say up in this oval that that segment CA bisects angle BAD. That's given. Now, if you have an angle bisector, it cuts the angle into 2 congruent angles. So let's mention that now. So what are the 2 congruent angles? Well, BAD was this entire angle, right? The whole thing. And it's cut into these 2 ones that I've done with the little green dots. And appropriate names for those, given the fact that there's multiple angles at vertex A, I could say, well, angle B to A to C, right? So that's this angle, angle BAC. BAC. Angle BAC is congruent to angle DAC, DAC, right? And why? I'm going to say this is the definition of a bisector. Now you say to yourself, well, wait a minute. Where's the bisector? Do you even know you have a bisector? It turns out I do. I do know that I have a bisector, so that's why this flows into here. So because of the fact that CA was a bisector of angle BAD, I can say next that angle BAC has to be congruent to angle DAC. Okay, let's move on. So I've got a side, I've got an angle, and now let's get the other side. And the other side is simply the fact that AC must be congruent to itself. AC is congruent to AC, and that's because of the reflexive property. Right? The reflexive property says that a thing is congruent to itself, or a thing is equal in length to itself, or equal in measure to itself. Well, at this point, I have clearly, and in the right order, I've got a side, an angle in between, and then a side. So I can now claim that I have my triangles are congruent, right? I can say triangle A, B, C is congruent to triangle ADC. And the reason is we've met the SAS congruence condition. Okay, and where is all that coming from? Well, we had this side, right? This side was given to be congruent. And then we had this other side, right? And we also had the angle that was in between them, the angle pair that was in between them. So this is our flowchart proof. And if I was going to write this out in a different format in a two-column proof, the important thing to note would be that this statement here, this statement has to precede this statement. And this statement is necessary for me to make this statement, right? So the things that are at the bottom of a flowchart proof require the things be listed that are above them. So that's an important idea as we shift over and look at an alternate format for this proof, something that we're going to call a two-column proof. Okay, so this is literally the same proof, right? That we just did as a flowchart proof, and we're going to look at it now in this two-column format. So there's things off to here, there's steps, and then I have a column that contains statements, and I have a column that contains reasons. I like this because when I highlight things, right, it shows me what I'm talking about. So this is angle BAD, and I can see, and it also highlights the segment too, right? And then these are my two congruent segments here. So it's nice to visually see what's being talked about. That's cool. Let's see. The thing I think I want to say first is because I've got listed up here that CA bisects the angle, I think I'm going to go ahead and talk about the fact that these little angles on each side have to be congruent to each other. So I'm going to say type of a statement. I want to make a type of a statement that says, okay, so I'm going to come down here and it says type of statement. Well, the type of statement I want to make is that two angles are congruent. So I'm going to click this, and this is just it has nothing to do with X or Y, but I just want to say that a certain angle is congruent to another angle. And the angles I want to talk about are angle BAC. So let me just type B to A to C. Right? And I want to say that that angle B to A to C, is congruent to angle DAC. So I'll go DAC. And the reason why those two angles are congruent to each other is because of this bisector, right? So I'm coming in here and I'm looking for a transitive substitution. Oh, here at the very bottom, you almost can't see it, but it says an angle bisector divides an angle into two congruent angles. So I'll select that reason. So now, and it has this button that says try. Is this going to be legit? And it turns out it is. So what's nice about this is it checks, do you have the supporting information you need? Normally, nominally, do you have a bisector, a segment, an angle bisector up above that? And I do. This is the bisector. You can see now I've got these two different angles. And I like this because, well, it's not showing the individual ones, but I do see that there's two angles there, and they are now congruent to each other. So we've got our two angle pairs. They've already listed here as given already this other pair of sides, right? So I know that those sides are congruent. So the final thing I need to do is point out that I've got another segment that's congruent to itself, right? AC is congruent to AC. So I need to say a segment is congruent to another segment. So I'll select that. And the segment I want to talk about is segment AC. And segment AC is congruent to itself, segment AC. And the reason for that is the reflexive property, right? Reflexively, a segment is congruent to itself, so I'll select that. All right, so now, and it says try it. Okay, so I'll try it, and it allowed me to get away with that. That means that the information needed was up above. Turns out there doesn't need to be any information. It just has to be the case that I really am talking about a segment and itself. The final thing we have here is, because now I can see that I've got these sides were congruent, I've got the angle in between I've established as congruent, and then this side I've established as congruent to itself. I'm ready to go ahead and write my triangle congruent statement. So I want to talk about a triangle being congruent to another triangle. And the triangles I have here are triangle ABC, right? A to B to C, and A to D to C. So So I'll try is congruent to triangle ADC. And the reason why these triangles are congruent, let's see, we ended up getting side angle side. So you can see side, there we go, side, angle, side. So I'll select that. And I'll hit try again. All right, let me do that. And now I'm just going to go ahead and hit submit the answer. Are you sure you want to submit this answer? I guess so. Well, look at that, huh? Look at that. And I think their steps could be slightly different from the ones that I did. But what I did is down below here. This is my proof. And you can see it's very much like the one that occurred here. So I'm going to have you try some of these today. Not a lot, maybe 4 or 5. But I just want you to try and shift from this idea of a flowchart proof where you understand the hierarchy, how things are related. It's kind of concealed here, for example, that this CA bisects angle BAD. They just listed both given statements at once at the beginning. I definitely require this top given statement before this one. So there's some dependencies here that we don't necessarily see. Okay, that is it. I hope you have a great Tuesday. I look forward to seeing you in class and online again soon. This is Mr. Roberts. Talk to you later.